So here's number 11 from section A2. Okay, let's do our graphic first. All right? Let's look at our graphic first. Where's my calculator? There it is. All right. So let's go ahead and put in sine over x cubed. And let's zoom 7 because that's the best trig zoom. And what's your opinion about what's going on with this as x approaches 0? I was wondering whether someone was going to say that. Thank you for not disappointing me, Trevor. So it looks like these things are going to infinity, and you can see in light blue that's exactly what the teacher's addition says as well. So there's our graphic. Let's see if we can confirm this. And how are we going to manage that? Well, how about we start by saying, is this first one indeterminate? I'm sorry, this is from the minus sign. Okay. Well, when we try to plug in our zeros, sine of 0 is 0, x cubed, 0. It's indeterminate in the form 0 over 0. So, what happens when we apply L'Hopital's rule to this indeterminate 0 over 0 form? I get cosine on top, and I get 3x squared on the bottom. Now, and here's the point I want to raise. When we try to plug in the zeros now, cosine does not equal 0. Cosine at 0 is 1. On the bottom, it's getting closer to 0. What happens when a denominator gets close to 0 but the numerator is finite? It gets really, really big. And in this case, since cosine is positive, and because x squared is always positive as we get close to 0, this is going to become big and positive. And at this point, we get infinity. Now, the classic mistake that gets made here is that, and I'll do this in blue, what it's not equal to. What it's not equal to is negative sine x over 6x.
Yeah.
I can't do this, although you want a tendency to do. What's my mistake? I can't apply L'Hopital's unless it's indeterminate 0 over 0 or infinity over infinity.
Oh, so it doesn't matter if it's 1 over 0?
If it's 1 over 0, that's not indeterminate. That's going to infinity or negative infinity. Yeah? Did you have that on your paper? Do you have negative sine over 6x?
Oh yeah, I kept going all the way till I got
Right.
0.
So every time before I apply L'Hopital, I say, is it indeterminate? And is it in this one of these two forms? If it's not, can't use L'Hopital. Got it? All right. And by the way, if I do the same thing with as x approaches, this was supposed to be the negative 1. If I do it from the positive side, we get to the same point. It's positive here and getting close to 0. We have the same going to infinity result. And that's number 11. And a lesson learned. You good, Emily?
Yeah. How
Okay.
can you go over 17?
No.
That just messed me up. Okay.
No.
I don't know what I did.